start this stream, we're gonna do a Kaggle challenge. When I start the stream. Okay, here we go. The stream is beginning. All right, guys. Okay, here I come. I'm coming, guys. I'm coming. Okay, hello world, it's Siraj, and welcome to my live stream. In this live stream, I'm going to complete a Kaggle challenge. The Kaggle challenge that I'm going to complete is called the Taxi Trip Duration Challenge. This is a Kaggle competition with $30,000 worth of prize money, so it's a big deal. And so in this video, I'm going to show you how to solve this challenge using a technique called XGBoost, which I haven't actually talked about before, surprisingly. Well, I talked about it once in my Math of Intelligence series, but that was a while ago. So what I'm gonna do, because this video is for my live viewers and for my recorded viewers later on, so I'm trying to make sure all of the time is used very well. So I'm gonna use some amazing tools, guys. I'm so excited to show you some tools. So first of all, Colab, by the way, Google's Colab, I haven't talked about it. We're gonna talk about that. We're gonna use some amazing libraries. It's gonna be a lot of fun. Okay, so I'm just gonna say 10 names and then we're gonna get started. Alex, I love you. Alina, Palestinian. Shivam, Pankaj, Audrey, Sabitri, Palestinian, Jonas, and Lax Lifters. All right, here we go. So hello from Hong Kong, by the way. All right, we got people from all over the world here. I'm so excited to do this, okay? So where do we begin? Let's take a look at this. So Kaggle is a website that allows you to compete with other data scientists, and you can collect prize money. It's a great business model that they've built over time. So companies have data sets and they want data scientists to work on these data sets and to complete challenges. So they give these data sets to Kaggle. Kaggle supplies the data scientists, you and us and all of us, and they supply some money, and then they earn that money through it's like a reward for solving it's a win-win situation. You provide them a prediction, they'll provide you with some money. So it's a lot of cool things. Okay, so Kaggle is awesome, and what I want to do is to look at this challenge. $30,000 in prize money. That's a lot of money. What they want to do here is, let's see what they want to do. What they want to do is predict the time for a ride in New York City. Okay, seems simple enough. Let's look at the data. What kind of data do we have here? Okay, so we have a training.csv file. We have a test.csv file. Okay, so we've got two different CSV files, and we have a sample submission CSV file. We have some data fields, so these are our features. Right? When we download this data set, we're going to see all of these CSV file, all of these features in this CSV file. And the great thing about Kaggle is we can just download it directly, just like this. Okay, so. But I'm going to do something even better than that. I'm going to show you how we're going to use this without even needing to download it. Okay, so. What we want to do is predict this feature right here, trip duration. That is our label. That is our Y value. These are going to be our inputs, right? Because we know that we want to predict the trip duration. So dependent on all of these other factors, these dependent variables, these independent variables, we're going to predict the dependent variable, the trip duration. Okay, so how are we going to do that? So normally I would start up a Jupyter notebook and I would start coding and I'd start installing dependencies locally. But today, I'm going to do this in the browser. So if you're watching this, what I want you to do is open up a browser window, another one, and type in colab.research.google.com. This is going to blow your mind, guys. So this is an internal tool that Google has been using for a while, and they open sourced it. And what it allows you to do is build Jupyter notebooks in the cloud. So this is a fully configured Python environment. You can install any dependencies you need, and you get 12 hours of GPU training time on a K80 GPU, an NVIDIA K80 GPU for free. No strings attached. For free. That is amazing. That is amazing. Okay, so let me show you what I mean. So you just go here. Let me do it again. colab.research.google.com, and I'm going to open a new notebook. Okay, it's loading up. It's loading up that CUDA runtime. It's got the GPU in the background, and I'm going to print out some Python. Hello world, it's Siraj. Okay, let's see what happens here. Great, Python's working. So what I'm going to do is I'm going to solve this challenge from inside of this Colab. I'm not going to do this locally. I'm going to do this in the browser, right? All of my dependencies, I'm going to install those in the browser. I'm going to do everything in the browser for this Kaggle challenge. Okay, so let's go ahead and get started. Well, first let me talk about the tools that I'm going to be using. So I'm going to be using, first of all, the data set we have here, our features, right? That's one part. The other part is the compute, the GPU. We have that already in the cloud. The other part is the Python environment. We have that in the cloud. And the last part is our algorithm. And so we're going to use Pandas for data pre-processing. We know we need to pre-process this CSV file. We're going to use XGBoost for learning, which is a Python library in and of itself. And we're going to use Matplotlib to visualize that data. Okay, so that's how this is going to go. Now, so what are the steps here? We're going to split it into training and test data. We're going to do some exploratory data analysis. I know you guys want to see some EDA. So we're going to see what do these features look like? How long is a trip? How much overlap between the training and testing data is there? And then we're going to use XGBoost on the model, and then we're going to train it, or we're going to use XGBoost on the data. We're going to train it, we're going to save it. Okay, so I got to explain how XGBoost works, but let's just start coding and then I'll explain as we go, okay? I cannot marry you. I am happily single, so that's how that goes. Thank you though for the offer. So we need to import this data set, right? So how are we going to import this data set? Well, ideally we could just, we could import it directly from Kaggle. So that's one way, just using the Kaggle API. Another way is for us to download download it, then upload it to Google Drive and import it from there. So that's what I did. So I'm going to show you how to do that. So we're going to have to install one dependency, and we can use pip from right within this. This is going to take about 20 more minutes. So hold your horses. This is important. Don't be asking how long this is going to take. God, this is some important stuff here. Go watch a prank video if you don't want to see this. No, I'm just kidding. Stay. I'm going to make this fun. Don't leave. Do not leave. Okay? Okay. So PyDrive is our dependency for us to be able to import data directly from Google Drive. Okay, so just remember that part. I'm going to talk about what I mean. So I have a few like sub-modules from PyDrive that I'm going to import, like Google Auth, because we're going to need to authenticate with Google. I'm going to import the drive, of course, because I need to be able to access Google Drive as well. I need to be able to access Colab. Yes, GANs are coming, guys. I know you guys, I love GANs, you love GANs, we all love GANs, but there's also an audience that hasn't had their appetite satisfied when it comes to Kaggle challenges and just like machine learning, not deep learning, machine learning. I think, of course, deep learning is amazing. It's a lot of fun, but there is a time and place for machine learning. Sometimes you just want to get a quick and dirty solution out there, and you don't want to have to wait for processing times that a neural network would take, and you don't have a lot of data. So I think a good exploratory step is to use some machine learning, specifically XGBoost or another ensemble method. There's bagging, there's boosting. We're going to talk about all this in a second. Okay, so that is our Google Drive dependency list. Okay, so now our data dependencies. Okay, so our data dependencies, and I'm going to answer some questions after I've imported all the dependencies that I need. So first of all, Pandas, of course. This is going to allow us to pre-process our data set. And of course, NumPy is always a go-to for any kind of matrix math that we might have to do in the end. We also want to be able to visualize this data set, so we're going to import Matplotlib. And I want to be able to also set this parameter for Matplotlib such that the figure is going to be a certain size that's going to fit in my screen. So I'm going to say, what is the width and height do I want it to be? I would say 16 by 10 for this screen. Another data pre-processing library is Seaborn that's going to help us visualize. And so scikit-learn is a great library, but what I really like scikit-learn for is the training testing split functionality. My GANs are showing. What are you talking about? My GANs are showing. Yes, exactly. Scikit-learn.model selection, import train test split. I mean, this is just like one of those super useful functions right here, train test split, because you're always going to need to be doing that, right? And then of course XGBoost, because we're going to be using XGBoost. And then what else do I need? What else do I need? What else do I need? I think I need to get make sure that Matplotlib is going to be inline. I need to make sure that it fits inside of my screen. Oh yeah, I can make a much bigger font. How about that? That's much better, isn't it? Thank you for mentioning that. Okay, so dot Unicode minus, and make sure that that's false, so that fits into my browser. Okay. Yeah, I think I zoom it. It's zoomed in, guys. All right. Okay. So now what I'm going to do is I'm going to authenticate. So I've imported my dependencies. Let me go ahead and compile that. Matplotlib is not right. Matplotlib. That's what it was. Okay, so now I've done that, and now that I've imported that, I'm going to authenticate. So now it's time to authenticate. So I'm going to say, authenticate me, my friend. Authenticate user, and create a new authentication object using Google Auth. This is just the authentication flow. I've got my credentials. So as long as you're, the great thing about using Colab is as long as you're logged into Google, which I always am, it's going to be very easy to just authenticate because it's already got your auth details. And lastly, I'm going to pull my drive from Google Drive gauth. Okay, so let me authenticate. All right. Do not be sleeping right now, okay? I don't care where you are. Do not be sleeping. All right, so I've authenticated, and now I want to access my data. So where am I going to find this data? Okay, I think what I'm going to do is say open notebook. I have this one. What is this one? No, this is nothing. Open another notebook. What else do I have here? What's in here? Nothing, of course. Okay, so I need to import some data that I have. So what I'm going to do is I'm going to go to my Drive account, drive.google.com. Make sure it's all good in there. Recent. What do I got here? Okay, so test and train.csv. So what I'm going to do is I'm going to get the shareable link for train.csv. Okay, so here's my train.csv. And here's the ID for it. So train, here's the IDs. These are both CSV files that I imported. So, and then here's test. Where's test? Test.csv, right there. Get shareable link. Okay. So here's test.csv. Now I have both of these IDs for both of my data sets. Now how did I do it? So import CSV Google Colab from Google Drive. So now you're watching me look at Stack Overflow to remember how to do this. Okay, so how do we do this? We have to say, how did we do this? Train and test. I did all that. Right. Oh, gotcha. Right. Okay. Thank you, Google Drive or person. And then once I do that, then I can say, import pandas and read it. Okay. So what I'll say is train downloaded, and now I have got my training data. and here's the ID of it. Okay, now here is my testing data, and here is the ID of it. Okay, hopefully this works, you know. I think it's gonna work. Now I'm going to, I already imported Pandas, so now I can say, here's my training data, and now print df.train.head. Let me just see if that works. I hope that works. I think that's gonna work. It's importing it from Google Drive. It's converting it into a Pandas data frame. And then once it's a Pandas data frame, then I can say, okay, now take df.train and print the head and like print a random row from it. Yes, okay, good. Good, good, good. Now, df.test equals pandas.test.csv, and that is test.csv. And make sure I've got both. I've got both the training data, I've got both the testing data. So let's look at this data set. Okay, so here is our data set. We've loaded it into Pandas. We see that it's got to pick up longitude, a pick up latitude, a drop off longitude. These are map coordinates. Okay, so how can we plot this out, right? This is map data. Latitudes and longitudes are XY coordinates on a 2D graph. So we could even graph a lot of this out, right? So let's check this out. Okay, so all right, so I've done that. Now I want to do some data pre-processing. So let's do some data pre-processing now that I've done this. Okay, so first of all, what is the, let's see, what can we do here? So we're trying to predict the duration of a trip, right? So what if we visualized what the average duration was? How about, let's try that. Let's try that. Let's try that. So, oh, is it not test.csv? Oh, thank you. Yep, there we go. That's my wizards letting me know what the deal is. Okay, so let's visualize how long was the trip. So that's our first question. How long is the average trip? So what can we do to predict what the average trip is? So we have our training data. And what we can do is we can say, let's see that trip duration feature. Let's use that trip duration feature. And we'll use NumPy's log function to regularize that feature, so it's going to be easier to visualize as a logarithm. Let's add 1 just to make sure that it's not overshooting the graph. And now we're going to create this this plot. So it's going to be, first of all, I want a histogram of the log trip duration. Okay, so the log trip duration. And I want to see what those values are. So I'm going to say, well, what's my X label? My X label is going to be, what are we measuring? So the log of the trip duration, which we've already computed. Okay, log of the trip duration. I think that's good. I think that works. Yeah. Log of the trip duration. Then we're going to have the Y label be the number of training records, like the number of data points. So we want to see the log of the trip duration, and let's see if that shows. It's definitely going to have an error in a second. Okay, what is the syntax error? The syntax error is, where is it? Line 2. Oh, gotcha. Okay, let's see what the deal is here. Dot values. Oh, this. Right. Right, okay, let's try it again. Okay, now in my histogram, I've got right. Okay, now train is not defined. Okay. Right. Oh, df train. That's what it was, not train. Df train. What do you mean train is not defined? Oh, right, df train. Yeah. What do you mean it's not? Oh, I keep using it, right. So every time I use it. Yes, okay, Matplotlib, check this out, check this out. So it seems like they're all there is this average, right? There is this average trip duration that they all kind of, there's a distribution. There's a distribution of which it seems like the median is about 6.4, and then it's all around there. So generally, the data all seems to be in the same like vector of values, like set of values. Okay, so okay, makes sense. What else can we do here? Oh, you know what'd be cool is if we could just visualize all of this as like how much overlap there is between the training and the testing data, right? So we've got training data, we've got testing data, and we don't want the testing data to be too similar to the training data, right? Because then if our model is overfit, we're not going to be able to know how to prevent that, right? So we want to make sure that there's not a lot of overlap. So let's sample, let's say for like 10,000 data points, we're going to let's say I'm going to, so let me tell you, what I'm about to do is plot out the training and the testing data in terms of their latitudes and longitudes. And let's just see what this looks like, right? So remember, we don't have a map of New York City. All we have are these like data points. And so if there is enough data, and if there is enough data, if we were to plot out all of these little latitude and longitude dots, theoretically, we could make a map of New York City just from that data. So let's try to do that. So let's have a variable for our longitude, and then we're going to set a border value. So I'm just going to like pick some -74, -74. We're going to have a latitude, which is going to be little less than that, 40. Maybe it could be -75, -75. I don't know. We'll fix this later. And then we're going to have a plot. So we have our figure and we have our axis. So using the subplots function of Matplotlib, we can create this. Okay. Of course it will. Yeah, it will look like a map. Of course. Number of columns is 2. Do I want to share this? Yes. Share the x value, share the y values, and right, so, okay. Okay, I want to take a second to just answer any questions. So ask any questions you'd like in the chat. I'm going to answer those. Meanwhile, while I code this, so I'm going to be like looking at questions. Scatter plot using the df.train. Pick up longitude dot values up to n for as many as there are. I defined n previously, and now df.train, pick up longitude, pick up latitude dot values again, so up to. Okay, so one great question is, why did I use the log? So logarithms are a great way for us to measure the relationship between different points in a data set. So logarithms follow a curve, and sometimes data sets can be very, very, very large. So on large timescales, we won't be able to see patterns that exist between them because they're so far spread apart. So when we use the logarithm, it kind of condenses that data, and we could see it in a better way. We can see patterns that wouldn't exist if we didn't use the log. And there's a lot of reasons for that, but are are you going to use TensorFlow? No, I'm going to use XGBoost, which is its own library. I'm not always going to use TensorFlow, guys. We want to try different libraries, right? There's other things out there. PyTorch is another one. TensorFlow is amazing, though. Okay, so one more question. What kind of RNN model will be suitable for C++ code generation? First of all, wow, that's quite an undertaking. C++ code generation. You would need a lot of code. GitHub's API is great for you. Just pull a bunch of C++ code. Now, how would we do this? You would be predicting the next, so character level RNN generation. Andrej Karpathy has a great blog post on this. You know, I think this has been tried before, like recurrent nets for code generation, and the results are not good. What I would do is actually try something, you know, out there, like a convolutional network for text generation. Not many people have tried that. Convolutional nets have been used for text classification, but text generation, not so much. Now, specifically, I would use a type of convolutional network that no one has ever tried. So probably like, oh, you know what? I use a DCGAN, Deconvolutional Generative Adversarial Network. Search DCGAN. DCGANs have been mostly used for images like Pokemon and things like that, but I don't think anybody's tried to use that for text generation. So I would say try that, okay? My internet speed is amazing. That's, okay. The log is magic, got it. So I'm going to explain that better next time. Okay, all right, where was I? Values and what color is it going to be? The color is going to be blue, so let's have this be blue. So the first axis is going to be blue. There's going to be one dimension. The label is going to be the training data, and the learning rate is going to be 0.1. Now, that's for that, and I'm going to do the same. Oh, we got a question here. What made you switch to a nonprofit model for School of AI? Great question. I did not start this to be charging people for access to AI. That just goes against why I even started this. And there's this idea in Silicon Valley. You can think about Silicon Valley as a state of mind of scaling for the sake of scaling is good. Like that is a good value to have. So when I was thinking about ways to scale, I thought, well, I'll just charge students, and then I'll use that money to hire people and just scale. But I am just fine. I'm doing just fine. I don't need to do that. I tried it. It was an experiment. I made some money doing that. But there are better ways to make money, and that's why. Okay, that's all I'm gonna say. But I'm just getting started, really. Like this was nothing. Okay, axis 1, pick up latitude, color. Oh, this color I want it to be green though, and this is going to be the latitude, right? Pick up latitude. Okay, and that's the value, and then now let's have a legend. No, let's not have a legend. Let's just show this plot now. Let's just show this plot. What do we got here? Of course there's going to be an error. What's our error? Oh my God. Oh my God. Oh my God. Guys, this is the School of AI, by the way. What you are experiencing is the School of AI right now. It's a state of mind. We are the School of AI, and soon we're going to have meetups across the world. I'm going to have point people in different cities. The plan is just getting started, by the way. This is just playtime. You know what I mean? Like this is just like 0.00000000001% of where we're going with this. So just think of it as an idea, a state of mind. It's a way of life, really. The School of AI is a way of life, of optimism, of swagger, of confidence, of a belief in the power of AI to do good for the world. Check out this. The next course coming out in a few weeks. Guys, listen, I've got this on lock. Just let me finish this Kaggle thing, and don't be asking me about School of AI right now, but thank you for asking about it. I love you guys. Okay, so check this out. We literally made Manhattan. look at this map. So on the left is our training data, on the right is our testing data. And if we look at it in this general way, they look pretty similar. But that is a map of Manhattan based only on the trip duration of all of these rides. Okay, so that's amazing, by the way. So let's just keep going here. What else do I want to do in terms of data analysis? Let's just say that's it. What else are we going to do here? What are we going to do here? Okay, so now I'm going to build this model. So I could do more, but I really just want to get to building this model. So now comes training the model part. Okay, so remember how I said xtrain, let's just call it xtrain, xtest, ytrain, ytest. Remember how I said scikit-learn has this amazing function, train test split? Here we go. We're using it right now. How easy was that? We're just going to say, I need a list of feature names. So feature names dot values y. So I'm going to explain what these variables are in a second. Test size is 0.2. Random state is 19. I don't know. Okay, let me talk about what I'm doing here. By the way, okay. So we need our feature names. So our feature names, the names of all of our features, we're going to pull from our training columns. So these are all of our features. Now we're also going to pull a y value. The y value is going to be the trip duration. So we're going to use the log for this. And so I'm going to say trip duration, and this is a value right here. And that's going to be, yes, df train. Thank you, df train. We got people on it. That's what I like to see. You guys are amazing. Trip duration dot values. Remember how I did that up there? I added one. I'm doing that again. Okay. So this is our input data, and here are our labels. Okay. So that's why I imported both of those. And so now I've done that. And I've got my training data, I've got my testing data, and now I'm going to import XGBoost. So XGBoost, which I've already imported, and now what do? We say XGBoost.parameters are going to, we're going to give this XGBoost a set. Okay, before we use XGBoost, I got to explain what this is. So let's get back to the explanation for a second. Where was I? Okay, first of all, well, also be asking questions. I'm going to be looking at this for questions, by the way. Okay, let's talk ensembles for a second, right? So when it comes to machine learning, ensembles, there's this idea of ensembles where you have multiple models that are trained on this data set, and then you can either combine those, you always combine those predictions in a certain way. The way you combine them is different. Sometimes it's using bagging, sometimes it's using boosting, and I'll talk about each of these, but right, so it's just a collection of predictors, right? These could be trees. So if it was trees, you could call it a random forest. It could be a collection of linear regression models. It could be a collection of logistic regression models. But we can classify ensembling techniques into bagging and boosting. So what bagging is it's an ensembling technique where we build many independent predictor models, right? So we have, let's say, a tree, a decision tree. We have another decision tree. We have another decision tree. We have another decision tree. And they're all trained on different parts of the training data, right? So we have, say data points 1 through 100, then data points 101 through 200, and data points 201 to 300 for each of those trees. They'll all be training, and then using some technique, we're going to combine those predictions together. So these are independent models that we then combine together using an equation to, it depends, like the equation for combining the predictions together depends on the model that we're using. So there's that, and then both overfitting, which is better. So actually, for overfitting, bagging is better. This image answers your question. But if we want to reduce the bias and variance more, we'll use gradient boosting. So let me go back here. So where was I? So that's bagging, independent models that all are combined to make a final prediction. Boosting is another type of ensembling technique where we're not making these predictions independently but sequentially, right? So the models are actually being optimized together. So one method of doing that is called gradient boosting, okay? So what that means is, in terms of gradient boosting, so check this out, hold on. Okay, so we have some loss function, let's say mean squared error that we want to minimize. Okay, by the way, if you are here, don't you dare leave during the math part, don't you dare leave. Second of all, I'm gonna wrap at the end and you can enjoy it, you can laugh, whatever, but don't you dare leave, okay? So here we go. So we need a loss function, right, to train any model. And so if we look at this loss function here, we'll see that this is actually a very simple loss function. It looks complicated, but it's not. Okay, so let's just segment this. Let's segment this out. Okay, so see the sigma with that E-looking thing that's called sigma. Let's just think about that part alone. What that is it's the sum of our errors. Okay, so it's the sum of our errors. And so our error values are, the difference between our prediction and our actual label. And we can find the difference there for all of them. So sigma means sum them all up, all of your errors up together. So that's this part right here. Then once we have that, we will multiply it by this alpha value and our learning rate. And so these can change, these are the tuning knobs for our model, right? This could be 0.1, 0.2, 0.1, 6, 7, 8, whatever it is. And there are different techniques to learn what the optimal hyperparameters for a model should be, right? So there's grid search, there is random search. There are different hyperparameter optimization techniques, so learning how to learn. Bayesian optimization currently is kind of at the forefront of hyperparameter optimization theory, a great research avenue to go down if you want to. Okay, so where was I? So this is us trying to find the mean squared error. And what we do is we use that error to compute a gradient, right? So the gradient tells us how off our model is. So in terms of the weights, the coefficients for our model, whatever the model is, need to be updated over time. So we'll use the error to compute the gradient, and the gradient tells us how to update our weight values. And so when it comes to gradient boosting, we're not just using the gradient to update a single tree, because we have multiple trees, decision trees. Decision trees look like this. Check that out. We're using the gradient to update all of them, right? So we train one, we use the gradient to update that and the next one, and the next one, and the next one. So that's trained, that gradient is used to update the next one. So it's like they're all linked together by this gradient that's updating everything. And so that's gradient boosting. And so XGBoost is a version of gradient boosting where it is designed for a set of decision trees specifically. And XGBoost is also like the top Kaggle model a lot of the time because it's easy, it's quick, and although I am convinced whoever won those competitions using XGBoost, if they just used neural networks, they would have done better, but they didn't have the resources or whatever. But yeah, I still believe in deep learning over anything else. But I think this is a good. My hair is different. It's silver. It's silver. See, this is the original hair that I'm going after. I just didn't dye it for a while, so it got kind of blonde. But silver is like my original hair. You know what I'm saying? So where was I? So that's XGBoost. It's a bunch of decision trees that are all optimized together using gradient descent. The gradient is updating everything, all of the trees sequentially. Okay, and not independently. Okay, so now. Okay, if you have to go to sleep, then definitely go to sleep. Thank you for tuning in. Okay, so now that was that. What can we do now? Now I'm going to say, you know what? I'm going to use the default parameters for XGBoost, and let's just say default params, because there's a lot of different parameters we could talk about. Subsampling, lambda, nthread, a whole bunch of different parameters. I'm going to be using the default one, df.train. okay? Okay, what I'm going to do, so I'm going to run this, and then while this is training, so training is unfortunately going to take a while, and I can't just train during a live stream. So what I'm going to do is I'm going to show you a model that has been trained already, okay? Okay, so over time, so this is a time, this data set changes over time. So what we can do is we can say, on the right, my right, you're seeing the actual pickup density at these times, and on the left, you're seeing the predicted pickup density. Okay, so this is using a trained model. It's predicting where rides are going in real time, over time. And this is what happens when you have a trained model, right? So once you train the model, you can visualize it using Matplotlib, et cetera, et cetera, et cetera. Okay, so that's it for this live stream. I just wanted to go over that. The code is going to be in the GitHub description, so definitely check that out. I have more coming out on that. And lastly, I'm going to wrap. So let me just wrap instrumental. Is this going to play here? No, it's not. Okay, let me find my phone. Okay, hold on. All right, wrap instrumental. Okay, it's time to wrap, and then also answer some questions. Grid search is time consuming. Yes, it is. That's why I would prefer Bayesian optimization. I don't want to. Okay, how can I make my own environment like Keras and TensorFlow? Listen, you don't want to do it yourself. You want to use Anaconda. You want to use virtual env. You don't want to have to do things. You want to use Docker. You don't have to mess with dependencies, right? We have tools now to automatically install the dependencies you need. Okay, so now I need somebody to say a topic because I'm going to freestyle rap. Okay? All right. Someone say a topic. Here we go. Here we go. Someone said R, the language. A. Okay, here we go. Here we go. I don't like to use R. I drop bars. I do it then back and back and back and back. R. Rar. I'm like a lion. Mar. Cielago is a place I want to go and drive a yacht in the sea, in the deep blue. Man, it's all good. Man, I'm like new. Every day I release a video. You try to stop me, it doesn't come back. I'm like Arsenio Hall. He was the guy who was rapping in the Apollo Theater, man, at night. Okay, XGBoost is it. That's it, that's it, that's it, that's it, that's it, that's it. We got a 30-second wrap in. Guys, we did this Kaggle competition. We visualized our data set. We talked a little bit about XGBoost. We did all of that in 40 minutes. You guys have learned so much, and I am so happy for you. Thank you for staying during this live stream. I'm so excited to have you guys here. I'm gonna try to do this every single week for you guys on Friday. Please subscribe if you haven't yet. Tell your friends to subscribe. That's what it's all about. I'm trying to grow this community, the School of AI. Together we can do that. So thank you guys for coming. For now, I've got to get a plane. So thanks for watching.